Hello and welcome back to another video. Today we're going to talk about finding coefficient of friction using torque forces. And one of the things that we're going to look at is how we can use torque forces looking at object in static equilibrium. So here I have a ladder that is rest on a wall and the ground, and there's a person on the ladder exerting a force of a force which is his weight due to gravity. And here there is another the force of that the ladder is being exerted from its center of mass due to gravity, and we're calling them mg1 and mg2. Now, the mere fact that the object is in equilibrium and there is some force acting down due to gravity, there must be an equal and opposing force, which is going to be my normal force. Also, the wall is going to be exerting a force on the ladder, and the ladder will exert an equal but opposing force, and that is going to be the force due to friction, which is the force here, such that the sum of forces in the x direction is going to be equal to 0, and the sum of forces in the y direction is going to be equal to 0. The forces in the x direction is going to be your force that is being exerted by the wall and your force due to friction. Now, the mere fact that the force due to friction is exerting an opposing force going in the in the next direction, then it is going to be negative as it is a vector quantity. So the force that is exerted by the wall plus the force due to friction is equal to 0. And the fact that the object is in static equilibrium, then it means that the force being exerted by the wall must be equal to the force exerted by friction. Now, if we look at the forces in the y direction, the two forces acting down, the force of the person and the force of the ladder due to gravity, is acting down, and of course there's a normal force acting up. Based on Newton's law, we know that the sum of the forces in the y direction must be equal to 0. So the force acting up, which is the normal force, and the force acting down, which is the two forces due to gravity, must be equal to 0. Since the force due to gravity is acting in an opposing direction from the force, the normal force, it is going to be negative. Again, force is a vector quantity, such that the force, the normal force, is equal to the force of the person due to gravity and the force of the ladder. Now you're being asked to find the coefficient of friction acting between the ladder and the ground, and that is going to be the coefficient of friction that is acting right at this point. Now there's another force that is acting on the ladder, and that is going to be the torque forces. Now the torque forces is going to be the force that is acting perpendicular some distance from that point or that lever where the ladder can be rotated anti-clockwise or clockwise. Now, if you look at the force acting down some distance from the lever, you will realize that these both forces will cause the object to go in an anti-clockwise motion. While if you look at the force that is being exerted by the wall, you will realize that that force will cause the ladder to move in a clockwise direction. So the forces that cause the ladder to move in an anti-clockwise direction plus the forces that cause the ladder to move in a clockwise direction must add to give me 0, such that the forces that cause the ladder to move in an anti-clockwise direction, the torque force of the person and the ladder, is equal to the torque force that is being exerted on the wall. Now, the torque force of the person, again, it is going to be that momentum force that is acting perpendicular to my lever, which is, let's go back to a diagram right here. And that momentum force is going to be the force acting down times its perpendicular distance, which is going to be the perpendicular distance here is 1.5 meters. And of course, the force acting down, let me go again. So the force of the person is going to be this force acting down times its perpendicular distance. That momentum force is going to be this force acting down times its perpendicular distance from the lever here, the turning point, which is 2.1 meters. Now the force of the person is going to be the force due to gravity, which is the weight of the person, right? So that is going to be the mass of the person times its weight. And of course, we're multiplying that by its perpendicular distance, which is 2.1 meters. And that is going to give us 50 kilogram times 9.8 meters per second times 2.1 meters, which is going to give us 1029 newtons. All right? Let us talk about the torque force of the ladder. All right, and we're going back to the diagram. So again, the torque force of the ladder is that momentum force acting perpendicular, some distance perpendicular from the axis of rotation here, which is that point where the ladder touches the ground. So that is going to be the weight that is being exerted from the center of mass of the ladder due to gravity. And that is going to be the mass times gravity, which is 75 kilograms, times 9.8 meters per second squared. And of course, we have to multiply that by its perpendicular distance, which is 1.5 meters. 1.5 meters. And that is going to give me 75 times 9.8 times 1.5, which is going to give me approximately 1,103 newtons. Now we need to find the torque force that the wall is being exerted. Right? Now if you should go to the diagram, you will realize that the perpendicular force, the perpendicular distance from this force that is being exerted by the wall is actually going to be the height between the wall and the ground, right? So this is the force perpendicular to this force. So that is going to be FW, which we don't know, times 5 point, let's go back and look, 5.5 meters. 5.5 meters. And that is going to give me 5.5 FW. Now we know that the sum of the torque forces, both clockwise and anti-clockwise, must add to give me 0. They must add to give me 0. Alright, so here we know the torque force that is being exerted by the person, the ladder, and the force being exerted by the wall and the ladder. We know that the sum of torque forces must be equal to the 0, such that the forces that is going to cause my ladder to rotate anti-clockwise the torque force of the person and the torque force of the ladder plus the force that is going to cause the ladder to rotate clockwise must be equal to 0. So now that we have this, we know that the torque force of the person plus the torque force of the ladder must be equal to the torque force of the wall as the object is in equilibrium. Right? So the torque force of the person, that's 1029 Newton, plus the torque force of the ladder, that is 1003 newtons, my bad, 1103 newtons is going to be equal to the torque force due to the force that is being exerted by the wall and the ladder. That's 5.5 times FW. Now, if I add these two forces, that's 1029 plus 1103, that is going to give me 1103 plus 1029, which is going to give me 2132 Newton. 2132 Newton. And that is going to be equal to 5.5 times the force due to gravity. 5.5 times the force due to gravity. All right. Now that I have that, I know that the force that is being exerted by the wall is going to be equal to 2,132 Newton divided by 5.5, and these should be Newton per meter, right? Force times distance is in Newton meters. So let's just make that quick correction. Newton meters, and Newton meters. So I'm dividing by 5.5, which is going to give me 3,387.6 Newton. And I know that the force being exerted by the wall is going to be equal to the resistance force. So the resistance force is going to be 387.6 Newton. And this is based on the sum of forces, of course, in the x direction. Now, I know that the coefficient of friction, mu, is equal to the resistance force, Fr, over my normal force, Fn. Can I find my normal force? Yes, I can. The normal force is equal to the force being exerted due to from the person due to gravity, plus the force being exerted by the ladder due to gravity. Right? So my normal force, Fn, is going to be the force being exerted by the person due to gravity, which is going to be the weight of that person, which is 50 kilogram times 9.8 Newton per meter squared, and that is going to give me 490 Newton plus the weight being exerted by the ladder due to gravity, which is 75 plus 9.8 Newton per meter square, meters per second square, which is going to be 75 times 9.8, which is going to be 735 newtons. So the normal force is going to be 1,225 newtons. Hence, the coefficient of friction that is being exerted where between the ladder and the ground is that frictional force divided by my normal force at that point, which of course is going to be my frictional force, which is 387.6 Newton, 387.6 Newton, divided by my normal force, which is 1,225 newtons, and that is going to give me 0.316. Of course, Newton will cancel each other, so the coefficient of friction is going to be a dimensionless quantity. And this is how you can use torque forces to calculate the coefficient of friction acting between the ladder and the ground. Now, we're going to look at more videos where we use torque forces to calculate resultant forces.